On question 24, 25, and 26, these three questions involve a branch of mathematics known as probability. And probability is something that we use to measure how likely that something is going to happen. And that something within probability is called an event. So probability as a number, can it be anything? For example, can the probability that something's going to happen be the number 2? No, that's impossible. A probability as a number is only ever between the number 0 and 1. Probability of 0, of course, means that it is never going to happen. It's impossible. Never happens. And a probability of 1 on the other end of the spectrum means that it's always going to happen, no matter what. Always happens. Now, historically, the study of probability in mathematics, it came from games, specifically gambling, and trying to measure within that game how likely that something was going to happen. And so a lot of probability questions involve games, specifically things like cards and dice. When we're talking about dice, we're usually talking about more than one. And when we're talking about a singular die, that is just one of them. And over here on number 24, it says an ordinary six-sided die, or sometimes it's called a fair die. And it's the same thing that you might expect if you play something like Monopoly. It's one of these guys. And the numbers that are on there represented by little dots, and those dots are called pips. So in the context of a six-sided die, what is an example of an event that would be impossible, that the probability would be 0? How about what is the possibility of rolling the number 7? Well, that can't happen, right? There are no 7s on that die, and so we would say that probability is 0. Never going to happen. On the other side of it, what is an example of something that would always happen? Its probability would be 1 or 100%. What is the probability that when I roll this die that I would get a number that is less than 7? Well, since all of the numbers on the die are less than 7, that means that it's always going to be a number less than 7 when I roll it, and the probability is 1 or 100%. Okay, let's dive a little bit deeper into probability. Probability is actually represented by a ratio. Probability, I'm pretty sure I spelled that correctly. It's a ratio that we ordinarily write as a fraction, and on the top of that fraction, it's what we want to happen, which we usually call desired outcomes. We count them all up, all the number of ways that we want something to happen, versus the number that's on the bottom is the total number of outcomes. Whoops. Okay, so let's look at the dice question that we were just talking about. When we write on our paper an event, we usually write it like this: P for probability, and the event, whatever it is that we want to happen, we put it inside of the parentheses. Let's say that I say the number 7 on a die. So I count them all up. How many different 7s are there on a number cube, a dice? A dice? No, a die. Well, there's a whole bunch of none. Out of, and then how many different numbers are there on a die? How many different outcomes? Well, you can roll the number 1, 2, 3, 4, 5, and 6. There are 6 of these things. And so, of course, that means we have a probability of 0. That's never going to happen. Okay, and then what about I change this to a number that is less than 7? So number less than 7 on a die. Okay, and then I count them all up. How many numbers are there less than 7 on a die? That's what I want to happen. Again, there are 6 of them. There's 1, 2, 3, 4, 5, and 6. out of 6, which is the number 1, or 100%, which of course means that this thing is always going to happen. Okay, let's switch this up just a little bit. Let's say I change this to what's the probability that you would roll an even number on a die? Well, how many even numbers are there on a die? There's the number 2, 4, and 6. That's a total of 3 of them out of the 6 total outcomes, which we could reduce as 1/2. Or if you wanted to, you could write that as a decimal 0.5 and maybe even 50%. As a measurement, that number is directly in the middle of this kind of continuum here in between never happening and always happening. 50% or probability of a half means it's as likely to happen as not to happen. Okay, now, this probability, this fraction that we're writing here, this is technically referred to as the theoretical probability. In theoretical probability, you can think of it as perfect world situation. It doesn't mean that's exactly what actually happens. Let's say that I actually roll this die. I'm going to roll this thing 2 times. Does this mean that one of those times is going to be an even number and the other time it's going to be a non-number? Not necessarily. What it means is if I roll the thing twice, I would expect one of them to be an even number. But it doesn't always happen that way. Again, if I roll this thing twice, here's some possibilities that could have happened. If I roll it twice, none of them were even. One of them was even, or both of them are even. And when I'm actually rolling the dice, then it's called experimental probability. And the relationship between those two is this. The more times that I actually conduct this experiment, the closer and closer the ratio of the number of times of getting an even number to the total number of times that I roll it is going to get closer and closer to this perfect theoretical probability of 1/2. So if I roll it twice, it's probably not going to be that close to 1/2. But if I roll it, let's say 100 times, the closer and closer it's going to get to that perfect real world 50% being even numbers. Okay. Probabilities are all over the place. You sometimes see them in games that you play. And if you call up, let's say, the weather app, you're going to see some probabilities here. And let's look at the 10-day weather forecast. And you can see Sunday here, it says 30%, and Saturday it says 60%. Here, let's look at those. So I'm going to write probability rain on Saturday. It said that it was a 60% chance that it's going to rain. 60%. So let me ask you a question. Let's say you're planning a trip and you look at the weather forecast and it says that it's a 60% chance that it's going to rain. Are you going to pack your galoshes and your poncho? Well, 60%, it's bigger than 50, so that means that it's closer to always happening than not happening. And so it's more in the rain's favor than not in the rain's favor, right? But most people probably wouldn't start packing their umbrella until something along the lines of 75%. Okay, so follow-up question here. If it says that it is a probability that it is 60% that it's going to rain, what's the probability that it's not going to rain on Saturday? 60% means 60 out of 100. Well, what's left over from 100? I take 60 from 100 and I get 40. I would expect there to be a 40% chance that it's not going to rain on Saturday. And in probability, these things are special. They're called complementary events. And complementary events are opposites from each other, and their total probabilities are going to add up to 100% or the number 1. Add up to 1. or 100%. Okay, so if I go back to the weather app over here, when it says on Sunday that it is a 30% chance that it's going to rain, take that away from 100, I can say that it's a 70% chance that it's not going to rain. So those principles right here can help you basically on those first two probability questions, number 24 and number 25.